Hi there, I am Huner. Recently I tried to learn more about Stephen Wolfram's physics project and I am having some new insights about the reality we may live in, because if it's true, it will change the way we see the world. We all know that since long, scientists are looking for the grand theory of everything, which is supposed to be a one-line description of our entire universe. Nothing new here, but Wolfram goes a bit farther and thinks that when we find the grand equation of everything, we can put it back into a computer and this should happen.
It's encrypted. Look at this place.
A fully fledged universe shall emerge from the simulation. This means the essential ingredient of our universe is computation, not the elementary particles. Think about this reality as a recursively analyzed equation, and we are in the mid-process. The elementary particles in our reality are just emergent and useful representations for our sensory organs and our measuring devices. Just like a game character, if becomes conscious, think his world is made of pixels, but we know this is not the case. The idea of a computable reality is nothing new, but this guy never gave up his toy simulations and recently made some big claims, which I think, if true, it means this movie lied to us, because the real world was inside the Matrix, not the other way around, and Agent Smith was the real hero, not Neo. To be honest, I am not happy with the new worldview. Maybe I haven't coped well yet, so if you are happy with your current worldview, stick to your local maxima and don't watch this video. Otherwise, take the blue pill and let's go back to the Matrix. Open your laptop, open a notepad file, save it with any name ending with .html, then reopen the file with a browser and place it on the right side of your screen. Put the notepad on the left side, type something, save the file, refresh the browser. If the text appears in the browser, we are ready to code. Let's try to build a universe. First, set the size of its dimensions. It will be a 2D world. Pay attention to the capitalized letters. Atoms are the building blocks. Each atom is a 3x3 pixel with 3 parameters to define its XY position and its color. Now we can place the individual atoms on the screen by setting their XY and color parameters. But a tiny portion of our universe contains 100 gazillion atoms. To recreate that tiny portion, we need to write 100 gazillion lines of code. But that's not how we program. Take one atom, change the first parameter to x. Now we can type a command to fill the x dimension with atoms from 1 to 1000. Save and refresh. You will see a green line on the top. Change the second parameter to y. Now repeat the line on the y dimension for 1000 times by typing this command. Now the entire screen is filled with green atoms. But now let's create the atoms if and only if the rule h is fulfilled. Now we need to define the rule h. As a starter, define h like that. Look, we built a triangle, but we don't want that. We want to build a universe. To do that, we need to find the rule that gave rise to our universe. But where is that rule? The search space is huge. What is that? A rule to create circles? It makes sense because many things in our universe are spherical. To create a circle, we need to define its center and its diameter. In our case, the center is 500 by 500 and the diameter is 200. Any atom outside the circle shall die and any atom inside the circle shall live. How do we know that? By measuring their distance from the center. If it's more than the diameter, the atom is outside. So let's put this rule in our code. According to Pythagoras, distance is the root of a squared plus b squared. Type that but ignore the root for now. A is the distance of x from the center, b is the distance of y from the center, which can be measured like that. When you define all the terms, press save and refresh. You should see a circle. You can zoom it by dividing this part by 20, but that's a simple shape because we haven't included time in our equations. Time changes everything. Even our universe was simple at the beginning, but then time changed everything. To add the effect of time, the state of previous circles should mutate the state of the future circles. For now, limit this effect to 200 time steps. In the code, set A to B and type a loop to iterate this part for 200 time steps. Don't forget to add a break here. A small capsule is formed. Zoom it like that. Now mutate the b parameter by this equation. A bullet is formed. Add dx to this part. You may say, all this code just for a rhombus? Wait a minute, we need to add colors too. In the RGB system, colors are set like this. In place of numbers, put T for time. This means atoms that survive longer will appear brighter. Put the color equation here, but rescale the red part by 3 and the blue by 0.5. Save and refresh. The final step is change the plus sign here to minus. Save and refresh. What? This is not our universe. Someone gave us the wrong equation. Let's zoom this part by changing the scales here. This is called Mandelbrot. Although this is not our universe, it is a worthy opponent. More on that later, but for now let's zoom this part. At this zooming level, the size of the whole shape is about the size of a football pitch. Of course, we are only rendering the visible part, otherwise our laptop will crash. To zoom more, we need to increase the time steps, but this will take much longer to render. But don't worry, some people already rendered high quality zoom-ins. Search Mandelbrot on YouTube and you will find many. Let's choose one from this channel and watch it together for a couple minutes. But remember, everything you are about to see is the result of this magic spell. The whole video is 2 hours long, and at some point the hypothetical size of the whole shape reaches the size of our visible universe. According to the principle of computational irreducibility, you can zoom this shape infinitely and you are still not going to be short of new emerging patterns. There are many other rules that behave like the Mandelbrot. They are called fractals or cellular automata. Emergent irreducible complexities are quite ubiquitous. In fact, most rules can give rise to interesting and progressively complex shapes if you mutate their input-output cycles recursively or iteratively. If we live in a computational reality, that means the theory of everything was already formalized by Alan Turing long time ago, and now physicists are looking for the sub-rule that has led to our unfortunate universe. But many physicists think that even if we find such rule, we can't properly simulate it with the classical computers, and even if we manage to do so, it will only give rise to a cheap knockoff universe, not a real one, because our reality is quantum and non-deterministic. Wolfram disagrees and claims that even quantum mechanics can emerge from simple deterministic rules. This disagreement stems back to Einstein and Bohr's era. Quantum mechanics have successfully predicted many physical measures such as the quantum entanglement, which states that if two particles are entangled, they correlate with each other even if they are universe apart. This phenomenon doesn't lend itself to any explanation other than quantum mechanics. Let's make a crude analogy. Let's say you live in the Mandelbrot verse and you communicate with pixel beams. The max speed is 2 pixels per frame. The initial resolution is low, but with more iterations as time passes, the resolution increases. And if the communication speed stays constant at 2 pixels per frame, then you should detect that everything are moving away from each other and the Mandelbrot verse is expanding. Now here's the interesting bit. Many points in this world seem to correlate with each other. For example, if a notch appears here, another one appears there instantly. These correlated regions seem to be entangled together. We know the deterministic global rule is responsible for these correlations, but here is the crucial experiment which proves we live in a quantum world, not a fractal world. If this guy with his free will makes a notch here, we will immediately see the notch appears in the entangled region, exactly as predicted by quantum mechanics. However, some physicists say superdeterminism may be a valid alternative explanation. It means our guy was also part of the system and his actions were predetermined by the global rule too. Guys, this is sad. If true, this is a real slap in the face of free will, but there is still a heated debate among the physicists on this topic, and I am still rooting for the team non-determinism. I hope my analogies are wrong, otherwise we are living in a very weird reality that we haven't prepared for. For the sake of argument, let's say we indeed live in a fractal world where everything is predetermined by a grand rule, and let's say you devoted your life looking for that rule. You do your research, you spend all your life in this quest, you get old, and the day before you die you manage to find the rule and the exact initial settings of our universe. You rush to your lab before your heart attack and quickly type the rule into the server. Big Bang happens, galaxies and planets start to form, life emerges, life evolves, dinosaurs appear, dinosaurs die, humans appear. We reach the point where I am presenting this video, and at some point in the future you will find the rule and rush to your lab again to type the rule into the server again and again. Congratulations, you just trapped yourself in an endless loop where your job is to create new universes and my job is to present this video, and everyone else lives a better life than both of us. So please, when you find the rule in the future, change the setting first. Don't repeat the same mistake again and again. Another unexpected consequence is that if anyone in the future finds the grand rule of our universe, they can resimulate it, and if they have enough computational power and can live for 13 billion years, they can reach your timeline and look at your internet history. The point, there is no privacy. All your life story is encoded in a rule and it's publicly available in the Ruliyat library. But the library seems to be terribly indexed. That's why Wolfram hasn't yet found the rule with his brute force approach. You may think simulating our universe require a powerful supercomputer, but that's not the case. In fact, you can simulate the universe on a very low-end computer because the frame rates don't matter for those who live inside the simulation. Only those who are outside can comment on our universe's performance and compare its frame rate with the other systems. Even if someone shuts down our server and switches it on again, we will not feel any difference. If you think this theory devalues our universe, you are right. I don't know what happens to the stock value of our universe if more people start to believe in this theory, because they will then say, what's the big deal? Anyone can create the universe with a notepad. Even even with a buggy JavaScript. They may go further and say we don't even need a computer. All we need is a simple Turing machine to simulate the universe. And who knows, they may go even further and say, oh, we don't even need that. All we need is some gibberish to start with. Think about it. Not so long ago, we used to live at the center of the universe. The sun was revolving around us. But this guy said no. Then we said, okay, we are the center of life. All life is about us. Everything is made for us. But this guy said no. Then we said, okay, at least our universe is at the center of existence. Is that too much to ask for? Well, now they say the rule that gave rise to our universe is one of money, and they are all computationally equivalent. What the hell? Is there anything special about us to be proud of? My next bet is consciousness. I hope no one devalues consciousness. In fact, I am all in for a blasphemy rule so that no one talks bad about consciousness, at least for another 100 years, or until some heresies find a better concept to hold on to. Until then, my unshakable belief is that consciousness is the most important emergence from the Ruliad, and we are at the center of it. Before you leave, take everything I said with a grain of salt, but I want to finish this video with a positive and a motivational note. I usually wonder if a universe with a humbler origin is actually a more impressive universe. Suppose you are going to a circus and there are two shows. One is a big muscular guy lifting a car and the other is a small child lifting a car. Which one you will choose to watch? I bet most of us are willing to watch the small child because that looks more impressive and more inspirational. Maybe right now you have an amazing idea that can make this world a better place, but you don't have enough funds to achieve it, and you think this universe is set up against you. But by our definition, your story and your achievement will not be impressive if the odds are not against you. Remember that your life story is an immortal piece of information. Your impact will be immortalized too. Your story is an integral part of a bigger picture. Without your story, the ground rule breaks. Your story is your pride, and I am sure it's beautiful. Thanks again for your time.